so for this one, I have y equals 1 minus x squared over 16, and I want it from -4 to 4. So this function is in terms of x, right? The function itself is in terms of x. My boundaries are in terms of x. They want it to go around the x-axis, okay? So this is what's important here, the x-axis. It's in terms of x, and it is a horizontal revolution in terms of x, all right? Which means the shell method is going to be what it's set up to do. I mean, the disk method is what it's set up to do right now. So I have it in terms of x, and I want a horizontal revolution. That is a disk method. All right, now, I will say that I have no breaks in this particular one, meaning I don't have to worry so much about an inner and an outer shell, because my outer shell is my function and my inner shell is my x-axis, which is what I'm revolving around. So there is no gap, right? So it's just going to be my function minus 0, right? Which is just my function squared. So for this one, I am thinking pi r squared is going to be the easiest thing to do here. It's already set up for that, right? If I were to rewrite it, that would be a pain to rewrite in terms of y, right? I mean, do you see why this would be nauseating to do in terms of y? And so, yeah, I'm going to do pi. My boundaries are -4 to 4, and my r is just this guy. So I'm going to say r squared. Now, he's not pretty to square, obviously, but it's better than rewriting him. And so I'm just going to go ahead and square him. Right, 1 minus, this is going to be 2 of these. So 2 of that would be x squared over 8. And then square that guy. So x to the 4th over 256 dx. And then take my antiderivative. Again, he's not pretty, but better than the alternative. So I get x minus x cubed over 24 plus x to the 5th over a ginormous, what's 1280, right? And this is pi, and we're going from -4 to +4. If we plug it in, we're going to get this. We'll get this first one. We get 4 minus 4 cubed is what, 64 over 24. I'm just going to write it out because I don't feel like doing it in my head. All right, plus 4 to the 5th is going to be, so we get 1024 over 1280. And from that, we're going to subtract a -4, which basically is going to work out to the same of all of this, but that's going to be negative. So that's 64 over 24. That's going to be a negative there, and that's going to be the same thing, 1024 over 1280. 4 minus -4. These are going to simplify to 8. -64 minus positive 64 is -128 over 24. Positive. That's going to be plus 2048 over 1280. That's up 2. All right. This actually simplifies to like 64 pi over 15. I'm going to just take that at face value, that's 64 pi over 15. In decimals, it's 13.4. They did give me feet. They actually gave me a measurement here, 13.4 feet. So this is volume, so we do have cubic feet there. So this is in terms of x. They have given me a y limitation here and an x limitation. So I am going to have to figure out what my other x is. But they wanted around the line x equals 2. And so I have two functions in terms of y, right? I have this function and this function. And then I am revolving it around a line x equals 2. And so it is a vertical in terms of x. So vertical in terms of x is going to lend itself to the shell method. And on top of that, I can't rewrite him. I can't rewrite y equals x cubed plus x plus 1 in terms of y. I can't. It's like, you know what I mean? Like, you can't solve for x there. And so in this case, you're going to leave it alone. But you have to consider what is happening here the whole time. So I am going to say 2 pi RH. That's what I'm doing here. Okay. What are my boundaries? Because my boundaries are in terms of x. They only gave me 1. So I need to plug this guy in to see my other boundary. I need to set these guys equal to each other. So I'm going to say 1 equals x squared plus x plus 1. You'll see that that equals 0. And you end up with like -1 and 0 as your options. But I've already limited my x to be a positive 1. So I know I'm going to go from 0 to 1 here based on that. So I have my 2 pi. I have my boundaries. What is my r? Well, my r is the distance from my x value to the line of my rotation. Normally my line of rotation is 0. So my distance from 0 to x is just x. But now I'm going from x to 2. And so my r here is 2 minus x. Right? So if I want to find out what this distance is, I take my line of rotation and I subtract my x. That's my r, right? Well, my height is the distance between my two functions. Well, my two functions are these two guys, right? So now I just have to figure out which one's higher. So I'm going from 0 to 1. If I were to plug in a 1/2, I would get this tiny fraction plus this tiny fraction plus 1, right? So this one right here is going to be higher than the y equals 1. You see that? This one's higher. So this is going to be the subtraction of the two. This one's going to be x squared plus x plus 1 minus my 1, minus this function right here. And so that is how I actually set this up. I have to consider my r changed and my h is the distance between the two functions itself. So my shell method is still easier here. It's really the only one we can do, but you do have to consider all of that. And so this is going to end up being like 2 minus x times x squared plus x, right? So you want to FOIL this guy before you do your antiderivative. So we get 2x squared, and then we got plus 2x minus x cubed minus x squared, right? And we're going to simplify this a little bit more. I'm going to say, oh, that's a cubed. I'm going to say a negative x cubed. Oh, that was a cubed. I was like, what am I doing here? So that's 2x cubed plus 2x minus x to the 4th, right? Minus x squared. So let me fix that really quickly. Helps to have the right thing. So I'm going to start with my x to the 4th. I have my x cubed. I have my x squared, and I have my x. And now I'm going to do the antiderivative of that one. So I have -1/5 x to the 5th plus 2/4. So that's 1/2 x to the 4th minus 1/3 x cubed. 2 over 2, that's going to cancel to just x squared. Don't forget you have a 2 pi out here, and you're going from 0 to 1 there. You end up with just all ones. So we have -1/5 plus 1/2 minus 1/3 plus 1. My common denominator is, 30? I think, right? So this is 6 over 30. This is 15 over 30. This is 10 over 30. That's 30 over 30. So we have -6 plus 15 minus 10 plus 30. So 45, so 29, right? Is that what we got? No, times 2. So we get 59. So that's 29 pi over 30. Don't forget your times your 2. Those cancel. So we get 29 pi over 15. That is my answer for that guy.